Indeed, my previous work prompted me to think more broadly about the role of hedgehog signaling in the tongue as a whole, beyond its function in taste buds. In collaboration with my team at the University of Michigan, we began investigating the expression patterns of various hedgehog signaling components during tongue development. Interestingly, among these, only GAS1 showed expression within the postnatal tongue musculature, and its expression changed following tongue maturation. This intriguing finding sparked our curiosity and motivated us to further explore the role of hedgehog signaling in tongue musculature.
So I think that the biggest challenges was the limited amount of tongue-specific research, particularly in the very early developmental stages that we were focusing on in our review, where there is a substantial body of literature examining hedgehog signaling in limb myogenesis as well as postnatal muscle and nerve regeneration, but much less of the work focused on tongue muscle formation and maturation. And so because of this, we really had to carefully evaluate findings across different muscle systems and determine where we could make meaningful parallels and where the tongue's unique anatomy and developmental processes required a different interpretation. So this made both the data integration and comparative table compilation particularly challenging. However, in many ways, the table highlighted just how different the depth of evidence is between limb and tongue muscle research. So at the same time, that gap became very important finding a review of itself, and it emphasized how much remains unknown about hedgehog signaling in tongue myogenesis and identified key areas for future investigation. So ultimately, I hope that this work will help encourage more tongue-specific developmental studies and laying the groundwork for future translational research, particularly in understanding and potentially treating, some of the congenital disorders that we talked about from disruptions in tongue muscle development.
Yes, as highlighted in the review, there remain important gaps in our current understanding. Moving forward, our research will focus on postnatal muscle maturation, as the role of hedgehog signaling after muscle patterning and organization is still not well defined. In addition, our recent work suggests that GAS1 supports embryonic muscle maturation and maintains the neuromuscular junction structural integrity through mechanisms that may involve pathways independent of canonical hedgehog signaling. Building on these findings, our future studies will explore non-canonical hedgehog signaling as well as alternative pathways, particularly those mediated by the co-receptor GAS1, to better understand their roles in lingual muscle development and function. The most promising applications involve developing therapeutic strategies for congenital anomalies, such as macroglossia or microglossia, as well as acquired conditions affecting tongue function, including dysphagia. In particular, approaches such as autologous muscle stem cell therapies are already being explored to restore tongue strength and function after injury or cancer. More broadly, understanding the regulatory mechanism of lingual myogenesis is critical for enabling muscle regeneration and repair following injury, disease, or postnatal muscle disorders. In this context, targeting pathways such as hedgehog signaling or co-receptors like GAS1, along with strategies to preserve the neuromuscular junction integrity, offers promising avenues for more precise and effective regenerative therapies.